Welcome to a lesson with Dr. Powell. Let's talk about how we can find the equation of a plane given 3 points in space. Let's say we have something like, I want to think of these points as being vectors. 1, 2, -1. Over here, let's say we have -3, 5, and 7. And say over here I have 0, 1, and 1. Okay. So be nice to know, like, what can we do, right, with all of these? How can we find the equation of a plane through this? Well, what do we need for an equation of a plane? We need two things. We need a vector and we need a point. Let's choose, well, any one of these points would work. Let's choose the easiest looking one, maybe this one right here, 0 and 1, as our point, our base point. Okay, so good. Pretty close now. Okay, we got a point. Next, what do we need? We need to have a vector that's orthogonal to this plane. How can we get something that's orthogonal to this if we have 3 points? Well, we have a way of finding something that's orthogonal if we have 2 vectors. From 3 points, we can make 2 vectors. And they'd both be in the plane. What if we just do an arrow that way and an arrow this way? Great. So I know these 2 vectors at least lie parallel to the plane if we think of them as emanating from the origin. However, we're going to think of them as emanating from this point. Okay, but let's figure out what these vectors are. And whatever these vectors are what we would add to this in order to get these. Hey, that actually tells us what it is. And let's kind of think. If the origin is somewhere over here, these 2 things are vectors. How do you find the one in between? We know this plus this is this. So that means that this minus this is that. So we just simply take this minus that. So we can do that to find this vector. So this vector is going to be 1. So 1 minus 0, 2 minus 1 is 1, and -1 minus 1 is -2. This one right here is going to be -3 minus 0, 5 minus 1, 7 minus 1. Great. Okay, so then what we need is the cross product of those 2 guys. Doesn't matter which order we do it in, because either way, we get something orthogonal. It's going to be in that line, maybe facing one direction forwards or backwards, but it's still going to be the same result or the same orthogonal direction. So it's going to determine the same plane, no matter which way we do the cross product. So I'll just write them right here as I'm thinking about the cross product here between these 2 vectors. To do that, take a cross product. So here, maybe we can, for a minute, we ignore, so if we're going to find the first part, we ignore the first column here. And we think about 1 times 6, which is 6, minus -2 times 4. So that would actually be plus, so plus 8. So 6 plus 8, so we're going to get 14. That's what's going to go. So we're going to get 14. And we'll put 14 right here. Next, let's figure out what goes in J. So we're going to kind of cross out the J and then think of 6 minus 6, looks like, right? 6 minus 6, which is 0. We have to change the sign when we do J's, but this time 0, change the sign. There's no change, it's a 0. So it's a 0 here. Okay. So we're going to get 0 here. And then for K, we would cross this out here and we figure 4 minus a -3. So 4 plus 3 would be 7. Okay, so that's the cross product right there. So this is going to be orthogonal to the plane. Now we can double check to make sure we did the cross product right. If we take a dot product of this with each one of these things, let's see what we get. 14 minus 14, that's 0, so that's good. And we do a dot product here just to check. See, 7. Yeah, it looks like it's right. Okay, because, yeah, Looks very good. 14 times 3 is negative 42 right here, and then 42 cancel out to be 0. So looks like we probably did our cross product right. This is orthogonal to both of these vectors, so it'll be orthogonal to the whole entire plane. So taking a look at this, what we have is we have our vector and we have our point, and let's use them. So our vector, write down right here, 14, 0, 7. And we dot it with any vector that emanates from this point to somewhere x, y, z. Now this vector right here is just simply the difference of this and this, so it's this minus that to get that one right here. So we're just getting any point that'll make a vector here from here to here that's going to be orthogonal to the v that we found. So we have x minus 0, y minus 1, and z minus 1. Notice this always kind of takes the form x minus the x coordinate of our point, y minus the y coordinate of our point, and z minus the z coordinate of our point, where our point of choosing was 0, 1, 1. Okay, and we just basically take the dot product of those, set it equal to 0, and there's your equation of the plane. So we get 14x and 0, that cancels, so it's not even there. So it's 14x plus 7z minus 1 is equal to 0, and that will define a plane in 3 dimensions. Thanks for watching.